Let's pay attention, okay? So this is 1.6 part 2, and in part 1 we've talked about imaginary numbers where I equals the square root of -1, right? Okay, and then we worked with that. So and then we ended yesterday or last class off by saying we're gonna rationalize the denominator because the denominator cannot have any radicals in it, right? Any square roots or any radicals. Like what if I gave you like a 44, like number 44, 3, -3 plus 5i over 15i. So if there is an I in my denominator, that's essentially having a square root in my denominator, right? Which I cannot have. Okay? So I have to get rid of it. How do I get rid of it? By multiplying by what? I over I. Okay? Why we multiply by i's, both top and bottom, is because let me just, it's going to be -3i plus 5i squared. I distributed out this I out, and on my denominator it's 15i squared, right? What is I squared? -1. So we have here -3i minus 5, because this is a -1, right? Remember we talked about our last class as well. Whenever there's an I squared, all I do is just cancel that out. And whatever symbol this is, a plus or a minus, is just the opposite symbol, right? So it's -3i minus 5 over, again, crossing off that I squared because it's -15. Okay? And because I have like three negatives here, -3i minus 5 and divided by -15, I'm just gonna take out all the negatives and make it look a little bit nicer by making it all positives. Okay? It's better to be all positive than all negative. Okay? Questions on that process? Something a little bit harder? 1 over 1 plus I. So again, I have an I in my denominator, correct? So what do I need to multiply by to rationalize the denominator?
I over I.
Nope. And we'll talk about y in a little bit. Huh?
I over 1.
I over 1, nope.
I over I. Okay, I heard 1 over I. Well, that's a piece. You know, I said that.
I over I, 1 over I over 1. Nope, nope, nope.
Negative I over negative I.
Nope. Negative I over negative I, nope. Come on, someone knows. What if I tell you that we multiply by its conjugate? Or it's all based on a special form? Christina? 1 minus I. Yes. Okay. Because it's 1 minus I, class, and they are conjugates. Okay? If they have the same terms, 1 and I, 1 and I, and the only difference is the plus and the minus, they're labeled as conjugates. Okay? So 1 times, in my numerator, 1 times 1 minus I is just 1 minus I, right? So 1 minus I goes on the top. And remember that special form, a plus b times a minus b, the difference of two squares? That breaks out to be a squared minus b squared. Remember that? I'm talking about this form here, a plus b times a minus b. That equals a squared minus b squared. Yeah. Okay. So that's just a squared minus b squared, right? And why we multiply by the conjugate is because that's 1 plus 1, which is 1 minus I over 2. Because the i's cancel out. They're poof, gone, right? If we multiply by I, just I, and whatever combination that you guys came up with, I over I, you would create another I. Meaning if I multiplied by 1 plus I by I, right? It would, yes, it would get rid of this one because that would just be I squared. But in turn, it would create another one plus I. Does that make sense? You just move the I to the other term. Okay? And whatever combination you guys want to do, just I with. You have to be multiplying by its conjugate to really get everything cleared. Okay?
Add the two.
1 plus 1.
Because in the I squared is not negative.
Yeah. So it's 1 minus negative 1,
Oh.
which is 1 plus 1. Yeah. Okay? Cool? Try this one together in your little groups. 5 minus I over 3 plus 4I. Try that one. Try this. So here we have to multiply by its conjugate, which is 3 minus 4I, right? So in my numerator, I'm multiplying 5 minus I times 3 minus 4I, so I'm going to just FOIL. Okay, foiling should come easy to you guys, so I'm going to quickly FOIL. 5 times 3 is 15. 5 times negative 4I is negative 20I. Negative I times 3 is negative 3I. Negative I times negative 4I is positive 4I squared. All over 3 squared minus 4I squared. Right? Any questions on what I got here? Simplifying what I can simplify. I see an I squared. So I cross that off. I cross off the plus, make it a minus. So it's 15 minus 4, which is 11. And then 20I, negative 20I minus 3I, that's negative 23I over 3 squared is 9 minus 4 squared is 16 I squared. So again, I see as I squared, so cancel that out. This minus turns into a plus. So 11 minus 23I over 9 plus 16, that's 25. That's your answer. Yes. Oh.
Oh, no.
Oh. Any questions? You can clap louder. I'm kidding. All right. We're good with that then. We're good with rationalizing the denominator. Right? Okay. Now we have to we have to learn 2 more skills. Okay? What's up?
Well, you got 16i squared.
This one? It's 4i times 4i. Yeah. So 4 squared is 16, I squared is I squared. So can you guys solve this one then? Square root of negative 81 over 16. What is that for? What is that? What does that simplify to?
Would it be 9i?
Yeah. Square root of negative 81 is 9i over square root of 16 is 4. So you can think about it as the square root of negative 81 over the square root of 16, like that, and that becomes like that. Okay? Cool? Alright, now we have to focus on solving equations. Let's actually just do this one first. Let's do x squared minus 121. Actually, plus 121 equals 0. Okay? So whenever you have one x value, what we can do is just solve. Okay? How do we solve this? What do I do? Subtract 121 from both sides, making this x squared equal to negative 121. And then square root both sides, right? The square root would cancel out with the squared, make x equal the square root of negative 121, which is 11i. That's your answer. Plus or minus. Yeah. Because whenever you square root something in an equation, you need that plus or minus. Okay? All right. Next little bit. What if I gave you an equation like this? X squared minus 6x plus 10 equals 0. And I asked you to solve, right? I asked you to solve that. What would you do? What would you try and do? Factor, right? So let's try and factor. Well, I know factoring, I need two numbers that multiply to 10 and add to negative 6. 10 and negative 6. 10 and negative 6. 10 is what? 1 and 10. 2 and 5. Nothing else, right? So this is not factorable, right? You cannot. So what we need to do is use the quadratic formula. You guys remember the quadratic formula?
Yes.
Yeah. Really quick then, a equals 1 in this case, b equals negative 6 in this case, and c equals 10. Remember, your a value is always with the coefficient of your x squared. The b value is always the coefficient of x, or whatever your variable is. And then your c value is your constant. All right? So the quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. Bring. Yeah. So all we do is just plug it in. Yeah. Just plug it in, negative b, so negative 6 plus or minus square root. B squared is negative 6 squared minus 4 times 1 times 10 all over 2 times 1. And then we just simplify. Yeah. So negative negative makes a positive 6 plus or minus the square root. Negative 6 squared is 36. Negative 4 times 1, that's negative 4 times 10, that's negative 40. All over 2. So this would be 6 plus or minus. Close. Negative 4 over 2, which is 6 plus or minus. Square root of negative 4 is 2i over 2. And now since this guy can go cleanly into both the 6 and the 2i, let's do it. That will be 3 plus or minus I. That make sense? If it doesn't go in cleanly, class, just leave it like this. Meaning, if your answer, right, if this answer was, let's say 5 plus or minus 4i over 2, I would just leave it like this. Okay? If your answer was just like this, right, because the 5 doesn't go, or 2 doesn't go into 5 cleanly, yeah, I'll just leave it like that. All right, but since this 2 goes into 6 and 2i, it cancels it out. It cancels out. You could just leave. That's your answer. Okay? Cool? Questions? Comments or concerns? Any life epiphanies? I know what I want to be. No life epiphanies? All right. So I will post your grade, or not grade,